you have basically seen different sorts of functionalities in the previous videos that allows you to utilize the large language models, whether it is to send requests, responses, pass the responses, and so on. In this video, we will delve into another library or another component within the ecosystem, which is LangGraph. These are some of the details or some of the functionalities that you will see within this video. We'll talk about state graphs, React graphs, compiled state graphs, MemorySaver, and human in the loop. So in any Python library, it is, from my perspective, good practice to check the API reference always and see or test some of the components before starting into even writing up some code and so on. And after writing some code, I believe it's also good practice to always be coming back to the API reference. With LangGraph in here, I'll be highlighting or I will be randomly going through some of the tools, some of the classes that I think will be useful or might be useful for any topic in a way. This is just the starting or the quick start from my perspective. It is not the full overview of all the API functionalities and so on. To start with, there is the graph. The graph, you won't be using a graph directly yourself, I assume. Just to, with a brief overview, there are two types of graphs within this library. The first one is the state graph, which you can think about it, it is more like a direct flow. They call it direct acyclic graph. If you have in mind a problem that you want to solve with a set of definitions, you go and use this type or this class, the state graph. The second one is the React graph. React, it's basically more making the LLM picking up on the tools, or it's more agents where the LLM itself will be picking up the required tool in order to be performed. It's more like reasoning and acting or something similar. Let me show you this. We will go this randomly. I will do this in front of you. State graph, searching here for the state graph. So what is a state graph? It is a graph whose nodes communicate by reading and writing to a shared state. The meaning here of a shared state, you can assume if of it, or you can assume it is like a dictionary in the memory or a specific structure in the memory where when you are moving within a graph, it gets updated. This state graph usually contains of nodes and consists of edges too. You can see here is a quick example in order how to import it. This is the state, which is there will be an instance that is going to be saved and it will hold the variables that you will be using while going through the workflow or within the flow. I will highlight two parts in here. The first one is add node. That's where you can add a node to the LangGraph. You will need to give it as a node, usually with an example in here. You can see here where you add to the graph a node. Also, you can add an edge. Adding an edge is where you jump from one step to another step, and that goes with one node that is the start, and the second one is the finish. Another important aspect from my perspective is add conditional edges. Add conditional edges is where you want the graph to decide based on a function where to go next. So you can assume that you have one node or one idea, which is to, let's assume, generate a number plate. But you want also to give the possibility for that node to be jumping to another thing. For example, restarting instead of going to selection of the design or selection of the number plate. That's how you need to utilize conditional edges. Actually, it is really helpful in certain scenarios. Although it is more structured, but there will be multiple pathways that can be passed by or traversed within the same graph. Another component is setting an entry. Another functionality is setting an entry point. As mentioned here, it specifies the first node to be called in the graph. And there is another method which sets conditionally the entry point to the graph. Also, let's check this function, the function compile. So the function compiles the state graph into a compiled graph object, which is uh, it's another attribute or another class within the LangGraph. So basically, when you create the nodes, when you create the edges and add all of the required functions, you need to compile the graph in order to be able to use it or creating it, use it while with running like a chatbot or running a specific example or running a workflow and so on. So after running a compile here, the method compile with the state graph, for example, the returned object will be a compiled state graph. There are a few functionalities or a few functions that represents like as a starting point for using the compiled state graph. The first one is invoke, and invoke is it does run the graph with a single input and config. You assume with invoke you run it in one go. While the other one, which is a stream, in stream it streamlines the output from the graph step by step while it's happening. So it's more like if you are generating token by token, it will streamline that. While with the invoke, it will wait until the end and then it will show it. Another methodology or another method in here, another function I really found useful from my perspective is the function getState. State retains a state snapshot. It means like what was in the state in that time. And I found that this kind of methods or this method really helpful at the time where there are interruptions or you want to see where did the flow stop for some reason and so on. Another aspect that I basically find pretty useful when working with LangGraph is checkpointers. Mainly one of the functions over there is MemorySaver. So we'll go through this as an example. You can see it allows to add persistence to your graph. It's more remembering about the previous interaction with the graph. So you can see here in the example, in the first part, when a graph was created and compiled, then when interacting, when the user interacts with the graph, there basically the person asks about the name, then the AI will respond, but then the next time the person asks about the name, the graph didn't remember that. While with the second part, after adding persistent using the function compile, as you can see up there, when there was another interaction or the same interaction happened again, the AI model remembered the name of the person. Another component that I find useful from my perspective is interrupt. So if I do interrupt in here, if I search for it, which is related to user input, so it is this one. So it is the functionality that handles a human in the loop. If there is, for example, you want the human to take a certain decision before going ahead with the graph, or if you want the human to review something before going further. You can see here from the examples that it is imported from LangGraph.types. There are two functionalities, interrupt and command. Interrupt is added within the functions of the graph within the nodes. So here, for example, you can see that this is human feedback and it is one of the nodes. When the graph arrives to that function or to that node, it stops after being invoked. So here, while in here the users were streaming, so you can see that there was an interrupt value. Then command is used to give the input from the user to the graph or to the state back again so that it can continues to run.